let's talk about an area problem. So we're going to do an area that involves triangle and a rectangle. We're given the area we want to enclose, and we're trying to find the appropriate dimensions. So this is the kind of problem that leads to quadratic problems, which is why we're talking about it. Rarely do you ever be given that this must have this amount of area, but hey, who knows? Maybe you're planting some stuff, you have a certain amount of stuff you want to plant, and they have different spaces, so you get your area that way. I don't know. Anyway, so the problem will be, we have a line, y equals 3x plus 10, like so, and there's a point we choose somewhere, say that's L, and this is our area. We want this area to be, let's say, 70. Why not? I like 70. You like 70? I like 70. 70's nice. Now, there should probably be some units, 70 square feet, 70 square meters, something like that. All right. Now, what do we know already? Well, we know that at x equals 0, that line is 10. Plug in 0 for x, you get that. That plus 10 is the y-intercept. It's got slope 3. We don't really care. It's just a number there, right? So I've already called the length here L. So this is L, this is 10. And then this, well, because it's on this line, we know that we just plug in L in for x, and that gives us our height. Now it's 3L plus 10, so we do 3L here, so that the height is 3L plus the 10, right? Get the 10 there, the 3L there, add them up, you get your height, the y. All right, so now what's our area? The area will be, well, the rectangle is 10 times L. And then what's the triangle? Triangle is base times height divided by 2, 1/2, right? That's half the area of the rectangle. So it's 3L times L all over 2. And that should be all equal to 70. And that's our fundamental equation. Now, if you don't like fractions, you can multiply everything by 2. Same as 20L plus 3L squared equals 140. So I just multiplied everything by 2. Multiplied, just doubled it, right? So if you have two things that are equal, and you double it, still have them being equal. The new stuff, that is. Still equal. All right, so how do we proceed? There are many ways to proceed. The easiest is to go to GeoGebra or Wolfram Alpha and get it to do the answer for you. We'll do that later. We will first start by doing kind of my favorite method for any problem of any nature, of any kind, pretty much. We guess. So, guessing. L equals, I don't know, 2. Why not? Let's try 2. So, 20 times L is 40, plus 3 times L squared is 12, and that's equal to 52. Too small. All right, so let's up our game. We're not that far off, relatively speaking. Let's try 5. I think, with the 20 thing, makes me a little nervous to get too high, because 20 times 5 is already 100. And then we add in, what is it? L squared is 25 times 3 is 75, so that's 175. Too big. And we're looking for that Nice in between, right? Well, let's say 52. What are we trying to do? We're trying to get to 140, right? The one problem with doubling everything is that one's tempted to think about the 70. 70 was the original area. 140 is just this artifact of getting rid of fractions. Anyway, so we want to be close to 175. Well, basically, so we have this 52, got this 140, we've got this 175, right? So this is like 35 in between those two. And this is something like, what, 90? Close enough to 90. It's really 88, I think. Yeah. But we'll just go with 90, because that's nice and easy. And we'll just say this is kind of like 30. All right, so now we've got 3 parts to the left and 1 part to the right. So you want to go down 1/4 from 5. Well, so the distance, there's 2, there's 5, and so 4 parts between 2 and 5, so it's kind of like a 3/4, and do one of that. So it's like, let's try 4 1/4. Actually, it would probably be reasonable to just try 4. But what the heck? I'm just going to do this one more time, and then we're going. So I'm going to go with 4 1/4. So what is 4 1/4? 4 1/4 is actually, let me do 4 1/3, because I see that there's a 3 times L squared, and so this is going to come out nicely if I have a 3 down there. I'm guessing. I can change these things. It's fine. It's wrong anyway. Seriously. Okay, so what do we got? We got 12 13/3, and that's 20 times 13/3 plus 3 times L squared, so that's 13 over 3 squared. So one of these 3's cancels. 20 times 13 is, what would that be, 260? Hopefully it's 260. And then 13 squared, I feel like that's probably 169. And that's all over 3. So what is this? 300 and 429. 429 over 3 are, what is that? That's 1. And then 12 is 40, 143. Pretty close. We were trying to get to 140, remember? Because we doubled it. And so that's pretty close. So it's about 4.3. All right, it could be actually 4.3. 1/3 is 4.33333. We're slightly over, so I should have gone with 4 1/4. But we'll see. All right, now I've done my guessing. I got a feel for this problem. I kind of know about what the answer is. It's probably good enough for that gardening that you want to do with the stuff. I mean, really, just go out 4 feet and 1/3 and you're good. Quarter, whatever, it's fine. Anyway, now over to GeoGebra. So we will type in our problem. And we can go back to the thing with the fractions, because why not? I'm not doing the computations. GeoGebra's doing the computations. So 10x times 3 times x squared over 2. Instead of L, we're using x because it likes x. And then we also want to find out when this is equal to 20. So we type in y equals 20. That gives us that nice horizontal line, and the intersection point is going to be the solution. Now notice that we have 2 solutions. One is negative. We don't want the negative one. We had our model here. It was to the right. That's what we want. Right? And so that looks like it's approximately, GeoGebra says it's approximately 1.61. All right? And you can get a better approximation here. 10L plus 3L squared over 2 equals 70. Use as a variable. And what do we get? We get this. Whoa, that looks ugly. You can tell I didn't pick these numbers to be nice. Oh no, I'm not going to do that. And what do we get? 4.2678 for the approximate. Wait, what? Oh, sorry. Why didn't somebody stop me with this GeoGebra? Maybe that looked wrong. What are we trying to do? We're trying to solve 70. There we go. .27. Sorry. Make sure that you put in the right numbers into these things. Don't put in the right numbers, you don't get the right numbers. You know what I mean? Okay, so now we go back to Wolfram Alpha. Yep, 4 point. And I should have seen it because I had already, but it's because I had a different problem on my mind. That's the problem. Stop paying attention, and that's what you get. And the exact form was pretty ugly, right? Whoa. Okay. Now let me do it. Find the exact solution algebraically. So there's a couple ways of doing this. One is basically how I would actually do this. So 3L squared plus 20L equals 140. I would leave it like that. That's a good form. Because I can just factor out that L here and get 3L plus 20. So equals 140. Now that L times 3L plus 20, that tells me that this parabola that I'm looking at over on the left-hand side, it goes through the origin here, and goes over here. L equals, oops, that looks like it's negative. L equals minus 20 over 3. There we go. That makes some sense. So it looks like this, right? And that's what we saw in GeoGebra. Goes through the origin here and through this other point here. Good. Oh, actually, while I'm over here in GeoGebra, there was another way we could do this problem with GeoGebra. Let me just happens every time. Okay, let me just clear that. What I can actually do in GeoGebra is graph my line. Let's go here. I already know from having solved this a couple of times now that my point, say, should be somewhere. There we go. Something like that, right? And if I do x of that point B, I get that x coordinate, so I can put a point down there, call it C. I throw in the origin, and then I also throw in that y-intercept. Now I can do a polygon, get confirmation, regardless of my algebra skills, because you have to always wonder whether you set the problem up correctly, right? There we go, value. There we go, 61.96. So it's close. That really should have been 4.3, right? There we go. Sorry, typed it in wrong. 3x plus 10. See? Okay, lots of ways to make mistakes in this stuff. Check and double check and check, check, check. Okay, 4.2. All right, so we're almost at 70. I can zoom in to get a little finer. I can't see the area. There we go. And 4.27. All right. Anyway, back to the algebra here. I had just figured out that we've got this parabola here on the left-hand side. These are the two roots for that parabola, and halfway in between is going to be minus 10/3. So that is our vertex x location. So I can write this thing as L plus 10/3. I'm going to have a 3 in front because it's in front of the L squared term. I square that thing. And then I did plus 10/3 because when I plug in the vertex, it should give me a 0 on that thing. And now, what is that value here? Well, that's plugging in minus 10/3 into that left-hand side. Minus 10/3 times. And if you put it in, you get minus 10 plus 20, or 10. It's good. If you factor out the 3, you'd actually get, pretty much the same thing. Look at the sign. Anyway, minus 100 over 3. So I should have known it was going to be a minus. Minus 100 over 3. And then it's equal to 140. Now you can square that out and prove that I've done this right. It's good. It's good. I think you should be checking that. I'm not going to check that. I'm just going to move on with my life because life is messy. All right, so now I can solve this thing. And these are not nice numbers, right? But it's not too bad. Not something you want to do on a Sunday afternoon. Maybe a Sunday morning. For 300, 420. Well, what do I want to do here? I guess I'd probably want to do, 3 into 99 is 33, so it's 173 and a third. I don't know. What's the best form? Maybe I'd want to keep it in thing, so what was it, 520 over 3. And now plus 10/3 equals 5 squared, 520 over 9. Then I take a square root. Do a plus or minus 520 over 9. And of course, the 9 is, square root of that is just 3. So I can do that. I'm sure there's some stuff like 4 I could take out. I don't know if I want to. L equals minus 10/3 plus or minus the square root of 520 over 3. Or minus 10 plus or minus the square root of 520. All right, so that's completing the square method, if you will. Finding the midpoint of the vertex. And what is this? This is, I'm going to guess that 520 equals 4 times 130. So the square root of 520 is equal to 2 times the square root of 130. And voila! Have the same thing as Wolfram Alpha does, right? Cool. One more method. So this is the quadratic formula method. So for quadratic formula, so let's say that this is completing the square. This is the guess method, and this is the quadratic formula. 3l squared plus 20l minus 140 equals 0. So the 3 is the a, the b is the 20, and the c is the minus 140. So L is equal to minus b, that's minus 20, plus or minus the square root of b squared, which is 400. And then you have a minus and another minus from the c. 3 times 140 is, what was that again? 300, 420, all divided by 2a. So that's divided by 6. And so that's equal to minus 20 plus or minus the square root of 820 over 6. And I am I'm hoping that 16 times, so I need to pull out a 16 out of that square root, give a 4 to get to the thing. So 16 times 820, or 820 divided by 16, do 1 1/4. That doesn't seem right. So I screwed up here. 4AC. Sorry. Since I actually want to pull out a 4, I don't actually have to do the multiplication out. But if you're just kind of messing around, you need to multiply that by 4 times 420, or 1680. 1680 or 2080. That makes some sense. $130. There you go. Whew. So quadratic formula is a plug and chug method, but the numbers get kind of a little bit bigger than one might like. There was, of course, the other method, kind of a similar quadratic formula, factoring out the 2, dividing by that. It's fine. All right, so that's the various methods for approaching this problem. Excellent.